Okay, so now if you turn to page 2, we are going to go over how to solve a system of linear equations by graphing. So if we look at number 1, we have a system. We know it's a system of linear equations because it's 2 equations involving the same variables. Now, the easiest way to graph, I think, is to put it into slope-intercept form. So I'm going to take my first equation, 2y plus 4x equals 12. I'm going to make it 2y equals negative 4x plus 12. Divide everything by 2, and I got y equals negative 2x plus 6. So first, I'm going to graph y equals negative 2x plus 6. I go to the y-intercept of 6. I go down 2 over 1, down 2 over 1, down 2 over 1. Okay, I connect the dots, and that's my line. Now, you should probably use a ruler when you're doing this, because to get the exact answer, a lot of times a ruler is necessary. I'm not using a ruler, but let's hope for the best. Okay, for this one, I'm going to add y to both sides, and then I'm going to add 10 to both sides. So when I do that, I get y equals 2x plus 10. So now I'm going to extend my line a little bit. And this is 6, 7, 8, 9, 10. So I'm going to start here at 10. And this time, when I go down 2, I'm going to go to the left 1, down 2 to the left 1, and connect my dot here, because that's a positive slope. So now, when I go to count my answer, this is negative 1, 1, 2, 3, 4, 5, 6, 7, 8. So it appears as if my answer is negative 1, 8. Why is negative 1, 8 my answer? Because that's where these two lines intersect. Okay? So I never just trust the graph. Now I'm going to take my original system. I'm going to plug in negative 1 for x, 8 for y, and see if it works. So 2 times 8 is 16, plus 4 times negative 1. 16 minus 4 is 12. So it works for this one. And 2 times negative 1 is negative 2, minus 8 is negative 10, so it works for this one. So not only did I solve it by graphing, but I also plugged it in to make sure that it worked. Okay, so now I'm going to do 2, 3, 4, and then we're going to turn the page and do 5 and 6. So you can either... What I think is best is if you think you know how to do this, do it on your own and then watch the video to see if you got it right. If you want to watch me do one more before you do it on your own, that's fine. But eventually, I want you to watch the rest of the video and make sure you got it right. Okay? So now for number 2, my 2 equations are 4x plus 2y equals 6. And 3x minus 3y equals 9. Now, before I put this into slope-intercept form, I noticed this top equation can be divisible by 2. So I'm going to do that because that's going to make it easier for me. And this means y equals negative 2x plus 3. And then I look at this one, and I can divide everything by 3. And that becomes y equals x minus 3. So now I'm going to graph my equations. I go down 3 for this one. And I go up 1 over 1, up 1 over 1, up 1 over 1. And that's that equation. And for this, I'm going to go 1, 2, 3, up 3. And if I go down 2, I have to go over 1 because this is a negative slope, down 2 over 1. And when I graph this one, I see that my intersection is at 2, negative 1. 2, negative 1 is where they intersect. So my solution is 2, negative 1. But I'm going to plug it back in mentally and make sure it works. So 4 times 2 is 8, minus 2 is 6. 6 plus 3 is 9. So I plugged it back in and it works. Okay, so now let me do number 3. And for number 3, I'm going to rearrange my equations into slope-intercept form. And when I do that, I get y equals 3x plus 4 if I divide everything by 2. And on the second one, I get y equals negative 4x minus 3. So when I graph these, I go up 1, 2, 3, 4. If I go down 3, I go left 1. Okay, I did not go down long enough. Here, down 1, 2, 3, over 1. And here I start at negative 3. If I go up 1, 2, 3, 4, it's a negative slope, so I go over 1. Now I'm making that a positive slope. I went the wrong way. Okay, if I start at negative 3, if I go up 1, 2, 3, 4 in a positive direction, I go over 1 in a negative direction. And this is my intersection, and that's negative 1, 1. And when I plug it in and check it mentally, it works. And then the answer to number 4, for the first one, it's y equals 4x plus 4. For the second one, if I divide everything by 2, I get negative 3/2 x minus 7. If I go down 1, 2, 3, 4, 5, 6, 7. If I go up 1, 2, 3, positive, I have to go 1, 2, negative. Then I go up 1, 2, 3, positive, 1, 2, negative. So that line looks like that. I did a really bad job, but let's hope it works out. And here I go up 1, 2, 3, 4. I go down 4. I go down 1, 2, 3, 4, over 1. And this intersection is negative 2, negative 4. And again, if you plug it in to check, it works. Okay, so that's 1, 2, 3, and 4. Hopefully you got those right. And you see that you just graph both lines, and where they intersect, that's the solution. And that also means those are consistent, independent systems. They have different slopes and one solution. Now, let's look at number 5. 2x plus 4y equals 12. X plus 2y equals 6. Okay, so I'm going to put these both into slope-intercept form. 4y equals negative 2x plus 12. Divide everything by 4. I get negative 1/2 x plus 3. Here, 2y equals negative x plus 6. And I get y equals negative 1/2 x plus 3. Now, what do you notice when I do that? When I put them both into slope-intercept form, even though it wasn't totally obvious at the beginning, we realize these are the exact same equation. So if I graph the first one and go down 1 over 2, down 1 over 2, it's going to be exactly the same as the second. So this is an example of infinitely many solutions. Infinitely many solutions. So that means this is what we call a consistent dependent system. So remember, it's consistent because it has at least one solution, but as opposed to the others that intersect, these are dependent because one completely follows the other. Okay, now let's look at number 6, and number 6 is 4x plus 2y equals 6. and y equals negative 2x plus 5. I'm going to leave the second one alone. This one I'm going to make 2y equals negative 4x plus 6, or y equals negative 2x plus 3. Now, when you look at these two, you realize, hey, they're going to be parallel. They have the same slope, but they have a different y-intercept. So right away, I know this is going to be no solution. But I'll sketch the graph anyway, and we realize the lines are parallel. So this is no solution, and we call that an inconsistent system. Okay? So when you change them both the slope-intercept form, you'll be able to see if they're parallel or the same line, or if they have different slopes. Okay? So that is the end of this video.